तो यूनिट्स होता है, यूनिट्स दो तरह का होता है, एक फंडामेंटल और डिराइव्ड। तो जो फंडामेंटल यूनिट होता है वो मेन यूनिट होता है, और उसी से डिराइव होता है डिराइव्ड यूनिट। तो फंडामेंटल यूनिट 7 तरह का होता है: मास, टाइम, इलेक्ट्रिक करंट, टाइम, मास, टाइम, लेंथ, मास, टाइम, लेंथ, इलेक्ट्रिक करंट, अमाउंट ऑफ सब्सटेंस, लुमिनस इंटेंसिटी। ठीक है। और डिराइव्ड यूनिट जैसे कि प्लेन एंगल, और प्लेन एंगल के जो एंगल होते हैं उसको वो होता है डिराइव्ड यूनिट।
क्या प्ले एंगल?
प्लेन एंगल।
प्लेन एंगल।
तो ये हो गया यूनिट की बात। अब डायमेंशंस। तो डायमेंशन में कोई भी क्वांटिटी को हम मतलब मास, लेंथ और टाइम
इंग्लिश में बोलना है, इंग्लिश में।
डायमेंशंस आर द physical quantities which we can written in time, length and mass. For example, if velocity is given, so velocity is equal to length, like mass upon second, so length upon second. So this is the symbol of length in dimension, and this is the symbol of s in dimension. So but the value m, there is no mass, so mass की power 0. So now dimension of velocity can be written as m0, l1 and s1. This is dimension. There are many quantities like this. For example, velocity, acceleration. So acceleration is length, sorry, this is -1 because length is in denominator now. Second is in denominator, so -1. Now length upon time into time. This is the formula of acceleration. So now we will write like this: L m is equal to 0, L is 1 and s is -2. So this is dimension of acceleration. As a force होता है.
What is the meaning of dimension of a unit? Means if you are saying dimension of velocity and you are saying dimension
when
of
we are writing
acceleration, so what is the meaning of dimension of?
When we are writing their formula in ml is mass, length and second.
Mass, length and
second.
Yani you means that the mass is denoting the weight of the object, and the length is denoting the mass, length and m, l and s. चलो ठीक है, next.
Like force. So force has dimension m, l, t and the ठीक है. So there are very many physical quantities, numerous, and
You do not derive the force dimension.
mass into acceleration is the force. So mass is m and acceleration I have derived m0. Time is m0, l1 and s -2. तो m मल्टीप्लाई हुआ तो m1 हो गया, यहाँ पे l1, यहाँ पे s -2. Okay. So there are many physical quantities like this. So this is dimension. Application of dimension is like that. either it's it will given that it is a force, and now you have to represent in mass and acceleration. We have to do the dimension of mass and acceleration in terms of mass and acceleration. So it's application of dimension. So when in the question it will given that there is a force and do the acceleration, do the dimension, the mass and acceleration, so we will write this only. Okay, so this is dimension. Now errors. So combination of error, it is known as combination of error, and there are errors of product, errors of division, errors of sum, errors of difference. So the error of product is delta z. Z is the sum, z is the sum or difference or product or denoted as. So delta A plus delta B is used for errors, for sum and for difference. For a product and for division, it is used as delta z upon z, delta A upon A plus delta B upon B. So this is for multiplication and division. Okay, now accuracy and precision. So accuracy and precision is that if we are writing a quantity like this 0.1, 0.1, okay, the true value, the actual value is 0.1, and we are writing as 0.
You have written 0.01.
The actual value is 0.01, and if we are for accuracy and precision, there are two topics. So for accuracy, if we are writing 0.2, 0.3, 0.03, 0.04, okay, so which one is more accurate? So 0.2 is more accurate, but
why 0.2 is more accurate?
Because it is near from the true value, the actual value that is needed. So it is more close to the true value. And if we talk about precision, so it is like
0.01 is not close, 0.02 is more close. Oh, you have written 0.02 and 0.03 and 0.04. Oh, then 0.02 is more close. Okay.
For precision, if we are talking like 0.02, 0.001, so this is more close. Why? Because it's have more numbers after decimal, so it is more precise value. So for precision, we don't need the true value. It's given in the question that many quantities are given. We have to choose a precise one. So the one which have more numbers after decimal is precise.
Precise.
So this is precise. Yeah.
Now next,
significant figures. It's like if it is given like 0.02, so wait,
0.002.
okay, So if the zeros are in starting, okay, we will not count it as significant figures. So 2 is only significant figure in this question. If it is there, so if non-zero digits are there, na? So non-zero digits are all significant. So 1, 2, 3, 4. So 4 significant value. Sorry, 1 significant value. Here's only 1 significant value, and here's 4 significant value. Here, so here we also not conclude these in significant. So only 2 is significant.
Why?
The zeros after the number is not zero, not significant. So 26 matlab 2 and 6 are significant. So only 2 digits are significant. In this, if the zeros are between the non-zero digits, so they are concluded as significant. So there are 4 significant. In this, it is written after decimal, so it can be concluded into significant. 1, 2, 3, 4, 5. So here is 5 significant.
Oh, after decimal it is significant.
Okay, so this is significant. And now rounding off. So rounding off is like 2.67. So it can be rounded off as 6 because 7 is above than 5. So 2.70. If and in the question it is given like you have to round off in 3 significant, in 2 significant. So if in the question it is given 3 significant, so 2.70. If 2 significant, so 2.7. Okay. So it is like that. This.
And if it is written to 1 significant.
So we have to do 3. Okay. Now, if it is below 5, so it can be it can be 2.60. Like this, 2.6 or 3. Now, rounding off is completed. And
if it is 2.46, if it is 2.43, then
2.40, 2.4 and 2. If in 3 significant, so 2.40. If in 2 significant, 2.2. And if in 1 significant, so 2.
Okay.
And if it is 2.57, no sorry, 55. So we have to check the previous number. It is 5, so it is odd number. So we will change and we will write 2.60 here. Okay. And if it is 2.45, and we will check that 45 is a even number. So we will write this only. We will not round off. After rounding off, we will write this only. There will be no change.
Okay. If it is 2.35,
so it is odd. 3 is odd. So we will change and write 2.40.
So it will be changed to the higher number only. Even if it is 2.115, then also
3.15.
2.15.
2.15. So 1 is odd number, na? So 2.20. We will write 2.2 into significant, and in 1 significant we will write 2.
And what about 2.35?
35 is odd number, so that तो ये 2.50, 2.4, so 2 अगर एक significant करना है.
Okay.
ठीक है. So this is rounding off. Now the last topic, vernier capillaire. ठीक है. So vernier capillaire and screw gauge, they two are measuring elements, मतलब by which we can measure. So firstly,
measuring elements.
like a scale.
Hmm.
So vernier capillary. Firstly, we will study vernier capillary. So in vernier capillary there is main scale reading, and vernier capillary scale, main scale and vernier capillary division, and main scale division. So n VSD is equal to n minus 1.
NVCD.
n VSD is equal to
VSD you have written VCD.
हाँ तो VCD तो बोल रहे हैं, VCD
NVCD.
हाँ is equal to n minus 1 MSD. So if we want to take out the ratio of 1 VSD, VSD है ना, 1 vernier scale division.
That was what I was saying, that you are saying NVSD and you are writing NVCD.
तो 1 VSD is equal to n minus 1 upon n MSD.
So what is the full form of this VSD and MSD?
Vernier scale division, main scale division.
Main scale division and vernier scale division. What is N?
N is number of vernier scale division. कितने
Okay.
division है vernier scale?
N VSD is equal to N minus 1 MSD. It means that MSD is 1 less than VSD, na? It means that if I have 5 VSD, it means there is 4 MSD. Okay, what is the full form of MSD? You have just told me, I have forgotten.
Main scale division.
Main scale division. Okay.
ठीक है, तो अब डिफरेंस बिटवीन ये हो गया, उसके बाद डिफरेंस बिटवीन मेन स्केल एंड vernier scale. So MSD minus VSD is equal to least count.
Least count.
Least count is the term that is used for measuring vernier scale, vernier capillary, vernier scale. So VSD minus VSD is equal to least count. Now screw gauge. So screw gauge has main scale.
Where it is used, this vernier capillary जो है,
for measuring very small quantities, very small, like a
quantities or quantities of what means very small, like atoms, molecules, or anything else.
no like a wire. A wire has very less diameter, na? So vernier scale is used for wire, thread, like this.
For measuring the diameter of a wire, for measuring the radius of a thread. Okay.
And screw gauge. Screw gauge is used for measuring more मतलब उससे भी कम, like hair, a part of मतलब a size of hair, a diameter of hair. So in this main scale and circular scale division, in this the least count.
These are the two types of screw gauge you want to say, main scale and.
नहीं, मतलब दो पार्ट है इसमें ना. स्क्रू गेज में जैसे इसमें वर्नियर कैपिलरी में दो पार्ट था, मेन स्केल और वर्नियर स्केल डिवीजन. इसमें भी दो पार्ट है, मेन स्केल डिवीजन एंड सर्कुलर स्केल डिवीजन.
ओके.
अब लीस्ट काउंट अगर इसका हमें पहचानना है तो हम करेंगे पिच अपॉन सर्कुलर स्केल डिवीजन.
Pitch upon circular scale division.
And pitch is nothing but the area that covered by the pitch is nothing but MSD, okay, main scale division, and the area which is covered by circular scale, the area covered upon number of rotations, जितना रोटेशन लगा उसको कंप्लीट करने में एक सर्कुलर स्केल, और जितना एरिया कवर हुआ अपॉन जितने रोटेशन उसको लगे उस एरिया को कवर करने में इस नंबर ऑफ रोटेशन. दिस इज पिच. यस, कंप्लीट.